So the next thing on this agenda is a really simple tutorial. It may be redundant since it looks like everybody's been playing around with GMAT anyway.
Hey,
but
Phil,
yes.
Before we start, real quick.
Oh yeah, sorry.
We talked about plugins before.
Yes.
So if Don writes a nifty optimization plugin, are there any hoops that I need to go to use different plugins, like registering a DLL or that type of thing?
You have to, and there's a file card that's called the startup file, and we'll get into that, and you just have to go into the startup file and point to the plugin.
That's really it.
I mean, in general, plugins are programming in C++. They're really programming things. But if you decide to learn how to write a plugin, you just register it using that syntax right there.
You have to compile the plugin with GMAT. So if Don writes a plugin for 2013A and you put it in your folder, you would just add that line and it would work. Yep. But if he writes it for 2012A, it probably won't work with 2013. Yeah.
Cool.
And we would approve you writing an optimization plugin if you want
Yes. When will that be ready?
to.
I need it next week.
Perfect. All right, so the first tutorial is in your book. It's called Simulating an Orbit. The only thing this does is it allows you an excuse to interactively open GMAT, edit some spacecraft properties, propagate it, and view the result. So that's really the first step before you go further into using GMAT more. So I'll talk through it since it's a short tutorial and since it's the first one.
I can see everyone's at a different place.
Yeah.
What you want to do is in GMAT, in the toolbar, there's an icon that looks like a planet with an orbit around it. It's the fourth icon. Click that, and that'll load the default mission and start you at the home screen.
Yep. So you should all be here. So nothing's been run. It's got the default scenario in the mission tree there, or in the resources tree. So, are we there? Okay. So the first thing, in order to make this a little bit more friendly, we're going to right-click default spacecraft and just rename it. So right-click it, rename it. The name the tutorial suggests is SAT. So we type in SAT, press OK, and if you fall behind or if you have a question, raise your hand and Rizwan and Steve will come around. So next, our SAT is renamed. We're going to open it up, and these are the properties for the spacecraft. So the default panel that opens up is the orbit panel. This allows you to set things like the coordinate system and the epoch and the state. So let's set the time first. The first thing to do is set the epoch format to the time system that you're interested in. So for this tutorial, we're interested in the UTC Gregorian format, and it automatically converts the default time to that format for you. So we'll just type in what it suggests, which is 22 July 2014 at a certain time, and then press enter. So I hear the errors coming already. So the reason, or the Gregorian format is a very specific format. It's really like a text format. So if you put like .8, it doesn't know you want 00 after it. So put the whole exact string in there, and it'll accept that. Next, we'll just set our elements in Keplerian. So for state type, there's all these state types in here: spherical, equinoctial. The default is Cartesian. Just come down to Keplerian, and it'll convert the default state into Keplerian format for you, which is really useful. So let's just type in the values. And so a couple asked about units. Over on the right, each field shows the unit that it expects. All right, so when you're done typing that in, you should be able to hit enter or apply, and if things aren't right, it'll give you a little warning about it. It suggests at this point you've set the spacecraft state, now save the mission. So to do that, you just come up to the toolbar and click Save, and then say pick the desktop and give it a name, like tutorial 1 or something. The extension is .script. And when you save it, it'll show up in the scripts folder. So you've saved this mission as a script, and now you can view that script if you want. Okay, so that's the spacecraft. Now the goal of this is to propagate it, so we have to configure a propagator. What we'll do is use the default propagator here, called default prop, just rename it to low Earth prop so we know what it is. So right click, rename, change it to low Earth prop, hit enter, and now that's the name of that propagator, and then double click it to open it up. So this is a new panel for this class, but it's sort of a combination between an integrator and a force model. So you can set all your force model parameters, you can set the integration, and it combines those two. So the integrator we're leaving as is. The force model, we're just changing it to a 10 by 10 non-spherical gravity with JR atmosphere. The JR atmosphere shows you a setup button. You won't have to touch it, but it's for setting up solar flux and such. And then we're going to add sun and moon as point masses. So select for point masses will bring up a box. You select sun and moon, add it to the list, and it'll show up in that box right there. And then finally, click solar radiation pressure to check that box. And that configures your force model. Okay, so we have a spacecraft, we have a propagator. Now we need to configure the view so it actually shows what we intend. So all we're doing is opening the default orbit view. You've seen this panel before. And we're changing the camera location so that when you actually run it, you can see the whole trajectory and not just a piece of it. So the camera location is the number given there in the tutorial. I'm on page 4, configuring. I'm sorry.
Research script.
Okay. All right. So I've done the spacecraft and I've done the force model. Is that? Should I go back to those or?
No.
Oh, okay.
You're under output.
Yeah, I'm under output, default
right.
orbit view. So that's the 3D graphics. Yep. Okay. And so this panel is showing the defaults for that 3D graphics window. Okay. So all we're doing here is the camera view has a coordinate system and a reference frame, so it's Earth-centered J2000 frame for the camera. And the camera is located at a vector from Earth. By default, it's 30,000 kilometers in the x direction, looking at the Earth. So because we've changed the spacecraft state, that camera location is no longer good for that mission. So if you were doing this interactively, you would run it, see that it's wrong, and sort of play with these numbers to get it to look right to you. But since we already know what it needs to be, those 3 boxes right here are X, Y, and Z for that camera vector. So we've chosen negative 60,000 kilometers, 30,000, and 20,000.
That shows the XY plane is off. Do you care?
That's right. So we want it off just to unclutter the picture. Yep. So over here on the right, on the left, sorry, are drawing options. You can choose to show the ecliptic plane, the XY plane. You can show wireframes instead of textures, various options like that. The sun line is a line from your origin to the sun, which can be useful. So for this, we're just going to turn off the XY plane to clear it up a little bit. And again, we're just checking, we're drawing the Earth and the spacecraft, so we don't need to make any changes there. So apply. All right, so we've created a spacecraft, a propagator, and we've set the orbit view to be useful. So now we need to actually tell it to propagate for a certain amount. So for this tutorial, we've decided to propagate to periapsis of the orbit. So to do that, we come over to the mission tree. So this shows, by default, there's a propagate command in there already. It's set to like 12,000 seconds just as a default value. So we don't need to add anything. We just need to open it up and view it. So this panel shows, there's 4 sections here. The section here, the top left, shows which propagator you're using. So we're using low Earth prop that we just configured. The right side shows the spacecraft that we're going to propagate. So there's only one spacecraft. It's called SAT. That's in that box. The bottom shows the stopping conditions. So you can propagate to any number of stopping conditions. You can say to periapsis for 1 year until something bad happens, and it'll stop at the first stopping condition that it gets to. So for this case, the default is elapsed seconds equals 12,000. We want to propagate for until periapsis is reached. So the way to do that is there's a parameter called periapsis, a parameter of the spacecraft called periapsis. So to change this parameter, you can just type in the box. It's easier to click the little ellipsis to the left of the parameter name, and that'll bring up a window that shows all the options. Okay. So this window shows all available parameters for selected object. So the object list has one spacecraft. You click the spacecraft, and it shows all the possible parameters for that spacecraft. So all we're going to do is come down the list here, click periapsis, and here's the dependency thing that I was talking about. When you click periapsis, it asks you what central body do you want periapsis in relation to. By default, it says Earth. You can choose any number of things, but by default, it says Earth, and you can just add it to the list over there. And yeah, so that's the list of stopping conditions that we want. Click OK, and it shows up here. And notice the condition went away, because there is no condition. All we're saying is propagate to periapsis. That's it. And so here's our only stopping condition. There is a tolerance here, so we'll get within like 1 times 10 to the negative 7 numerically of the periapsis exact location. So if you want it tighter than that, you can reduce it. Okay. Other options here, you can propagate multiple spacecraft, you can propagate with multiple propagators, you can do multiple stopping conditions, you can do forwards or backwards, you can generate the STM as you're doing it, or the A matrix, and report that out. All we're going to do here is simply go to periapsis.
What's A matrix mean?
Jacobian.
Yeah,
It's
Jacobian.
actually documented. This is you can only access this through one of the plugins that's alpha.
Okay.
But it is the partial of acceleration with respect to the partial of x dot with respect to x.
That's good. As far as I know, there is no name for that. So A matrix
Yeah,
is
it's
fine.
the Jacobian is
Yeah.
the general word, but A matrix is what it gets called in aerospace.
So if I wanted to stop on periapsis or elapsed time, how would I do that?
You would add a second block down here for elapsed
Or what, anything else?
days or seconds, elapsed seconds. So put in, I don't know, 5,000, I don't know, that's low, 20,000 something. So that'll say stop at periapsis unless it goes beyond 20,000 seconds. It'll stop at the first
Basically
one.
Tracks them all, whichever one it hits first stops.
Okay, that was mine. Okay.
Yep.
And what if I wanted to stop on the third periapsis? What's the
Which is
simplest way
very
to do
common.
You have to shut it down and run it 3 times.
Okay.
You put a for loop around it.
Yeah,
So-
that's right.
For I
Okay.
equals 1 to 3.
Okay, so that would actually involve scripting.
You don't have to. Right now, when we need this in the future, you cannot cut and paste events, so you would have to be careful how you set up things in the GUI, but you would create a for loop, and inside that you would insert your propagate.
Okay.
So that might be something for the future, because there's a condition there that you could set for periapsis, and you could say third periapsis.
The syntax unquestionably allows us to put something in like a repeat for
Yeah, yeah.
and just do it. And it is done often enough that it's a useful feature, and I'll write it down for a feature.
Yep.
Okay, thank you.
And if you're curious about it, you can click the show script, and it'll show you what the actual command looks like. So, if I accepted this multiple stopping condition thing and clicked it, you would just
Okay.
put a chain of stopping conditions with commas.
And it doesn't matter which one it hits first, or the periapsis hits first.
The order doesn't matter. It'll.
Okay.
I mean, I guess if 2 things happen simultaneously, but yeah. That's right.
Do I always have to click apply before I hit OK?
No. Nope, you don't.
Okay closes the window, so if you wanted to apply it and then change something else, you can apply.
Okay. But if I hit OK,
You
it
can close
does.
the window and then you know
It does
apply and close the
Okay.
window. Yeah.
Okay, so I just added my periapsis back. And now at this point, you just click the blue run button at the top, and you'll get this window. The useful one is the 3D view. So you can zoom out a little bit, and you'll see that we started at the apoapsis, it looks like, of a elliptical orbit, and it stopped us right at periapsis there.
So if I have more than one stopping condition, how do I get rid of one?
That's a good question.
I just went to the end of the words and then just.
Oh, yeah. You can double click it and just delete the phrase.
That's what I did.
Oh, and
I
At
don't
least
know.
I did, and gave me an error. It
Oh.
told me
Oh.
I had a stopping condition, it's not defined.
Oh.
Interesting. Yeah, I can
Oh, I've
write
heard
that
of
down.
Before. Yeah, just told me.
So that's it. Now, if you were interested in the state of the spacecraft after periapsis, you can look at the command summary for that, and you can view it in, ICRF coordinates. And
When did it, so you went to.
it's a command summary for the propagate. Yeah, after I ran it.
Okay.
And it'll show you that, you hit periapsis on the 23rd of July at, 8:48 p.m. And it gives you the state there. And nice thing is it gives you like velocity at apoapsis and all kinds of useful parameters. Okay. Any questions on that tutorial? That was really basic and straightforward. Yes.
Minor question: when I'm adding a propagator, the default name is always like something like
Mhm.
the lap settings, go long name.
Oh.
Like it didn't come up as like propagator one. It came up with this whole setting.
Oh, really?
Showed the condition for the propagator. Like every time I would add it.
That sounds like a issue. Yeah.
Yeah.
We're now in test.
Yeah.
It's a beta test.
Put a bunch of the same.
So what did it do?
Okay, so I'm going to show, take a step back and show the script for this. So you have a printout of the script that generates that mission in your folder after the end of the tutorial.
Yeah, same condition twice.
So how would you do this in using the script language instead of the GUI? Okay, so maybe you just enjoy writing scripts more than clicking panels and things, and you want to do this purely in the language. You're Steve Cooley. So the first step, this is just following the steps of the tutorial. You would write something like create spacecraft, and then you would name it sat. And then the next step is to give it an epoch. So you would add the next 2 lines. So the syntax here is date format equals this UTC Gregorian value. You would say the epoch of it is that string in single quotes for the string. That will accomplish the first step. And then you would define the state in Keplerian orbit, or state type. Okay. So actually, this says.
Pardon the interruption. Your conference begins later.
All right. So this line says when you open GMAT, display the state in Keplerian format, and then you're providing the Keplerian state here. This line is actually not mandatory. So the reason why it's called display state type is you can omit this and just define your state in those coordinates. And when you open GMAT, it'll actually show you the Cartesian conversion of that. So this one is just for GUI.
It's
Is
also
that true?
what gets written to the script. So display state type covers what type should be displayed in the GUI. When you save your mission, what will be saved to the mission.
Yeah.
So it
But it's
doesn't matter which
intended
view.
for the GUI to, yeah.
And there is a known issue. I'm sure every one of you are going to see it with the spacecraft texture map. Like sometimes it's missing a piece. That'll be fixed soon.
So this entire block is everything for defining the satellite, the spacecraft. If you did this tutorial and you save the script and you look at your script, you'll see like 3 pages of script language there. That's because of that I mentioned before. When the GUI saves it, it saves values for every parameter possible. So the best practice here, if you're writing script, you only have to write the things you care about, and it'll fill in defaults for the rest. So to define the propagator, you would create a force model. This is special syntax. Create a force model, create a propagator, and assign the force model to the propagator. So a propagator is an integrator plus a force model. The force model you define here. The propagator you define, set the integrator settings, and then give it a force model to use. And then you fill in your force model parameters. So central body is Earth. We have a concept called primary bodies. Theoretically, in a general system, you can have multiple non-spherical gravity models all operating at once.
Cool.
And so this is intended eventually for that purpose. Right now we can only have one primary body, but yep. So primary body is Earth, and that enables this gravity field section. So we're saying gravity field, degree and order are both 10. The atmosphere model is GK Roberts. And SRP is, we're turning it on. So if you want
that again regarding the primary body?
So theoretically, GMAT was designed in such a way that you could say, my central body is Earth, my primary bodies are Earth and Moon, and you could define non-spherical gravity models for both the Earth and the Moon and have them both active at once in your force model. Okay? So the caveat there is that's the way GMAT was intended and designed. It proved, well, Steve can speak to this. My impression is that it proved impossible to test accurately because no other software that we test against does this.
Most other tools do it now. We just design
Okay.
the interface so that when we get there, we don't have to break the script.
Yeah. Okay.
How do we generate an ephemeris?
I can show that in a minute. I actually have a thing. Once I finish this, I'll show you how to do that. It's really easy. For the orbit view, we're just creating an orbit view, adding Sat and Earth to it. The orbit view is something you probably don't want to script by hand just because it's so complex. But if you wanted to, there's how you set the viewpoint vector, and we're turning the XY plane off. Really basic stuff. And then we start with the mission sequence. So the first step is to give a begin mission sequence command, and then we fill it in with a propagate statement. So this one we're saying propagate using low Earth prop, use sat as the spacecraft, propagate sat, and then the stopping conditions go in that curly brackets. We just have periapsis as the only stopping condition. So that's there. So that's the scripting. The question was, what if you wanted to add an ephemeris file? So the way to do that is, that's an output type. So you would come over here, right-click on output, add, and then there's an ephemeris file block right there. Click ephemeris file, and you have a new object called ephemeris file 1. Open it up, and so you can generate either a CCSDS or an SPK ephemeris. So I'll stick with CCSDS. Give it a name. You can give it an interpolation order. You can subset the time range that you're writing.
Now, can you write variable step ethans?
By default, it does, yes.
Okay.
You can either, it will either interpolate to a requested step size, or at default, it's the output integrator steps.
Okay. Oh, great. Okay.
Yep.
Yeah. Sorry.
So actually, I can put in a 60-second ephemeris right here.
Ah, okay.
And then when I hit go, remember I'm generating a new output, so I'm going to rerun it again. And now in the output tree, there's your ephemeris file, CCSDS format. And if you go down, you'll see 60-second blocks.
Where did you set the 60 seconds?
There's a step size.
Where it says integrator step, just put 60 in there.
Yeah.
Oh, just then.
Yeah, you
Yep.
just type 60.
So it's not an option.
No, it's just, yeah. If you put a number, it assumes you're talking about seconds. And you can change the epic format of this. Actually,
Of course, this is going to beg, can you ingest free flyer EFEMs, stk.e files?
we can propagate SPK ephemeris, and
No,
that's
can
the
you-
only format.
Can you read in other
Oh,
formats?
no, not right now. We can't
You can read
for
it.
state.
A
Oh,
spice
Yeah.
someone else, I'm sorry.
You can
Yeah,
read a
you
spice
can read
file,
a spice ephemeris, but no other.
but that's
Yeah,
not what you're okay.
not
Not
SPK.
an E file or a free flyer EFEM
That's
file?
correct.
You could probably easily write a map out and do the reformatting.
SDK
No, you
can
could easily-
generate a spice file. So if you wanted to take something
Yeah.
from SDK, you could generate a spice file and then pass that
Mhm.
over. I don't know about what Free Flyer can do.
Yeah, it's just we got thousands of JWs to EFEMs and
Yeah.
free flyer format, EFEM format, and an E file
This is a
format.
major feature area that we need for sure. There's just no question.
But I don't have CCSDS in yet.
Yeah, so we covered some of this, but if you wanted to propagate for elapsed days, you would just put elapsed days equals 2. That's really easy. If you want to, here's a common thing. If you want to propagate to the ecliptic XY, we don't have a parameter that says ecliptic plane, but you can just, there's a coordinate system. You can't read that, but it says Earth J2000 EC for J2000 of the ecliptic. You would propagate to the Z coordinate equals 0, and that would stop you at the ecliptic XY.
Okay, so this is one of the JWST issues, is RLP XYZ is not the same as a coordinate system that's Sun, Earth, line based.
It's very similar.
Yeah, Berry Center versus Sun, Earth.
So one point is the sun, the other point is the Earth Moon Berry Center.
Right.
Yeah.
So
that's
we're ahead of schedule, I think. Are we?
You don't have to show how to do this, but that's something
You
that's-
unquestionably can do that.
Okay, because that's,
In brief, you would go into solar system.
yeah.
Here's the
and
10-second.
create a special point Berry Center. You would make this be Earth Moon, which it defaults to.
Yep.
And then in your coordinate system, you choose that as the secondary.
Okay.
So you can do a
Primary would be the sun, and Earth Moon Berry Center as secondary.
So do you guys have an
What, object
coordinate
reference?
system defined in
You
here?
build it. So
Okay, so we would build it. Okay,
so
that's
basically,
great.
if Joel
That's
sets
wonderful.
primary to sun,
Ah, sweet.
so there's your coordinate system.
Yeah.
Just remember
Well,
which one is stopping.
What's its origin?
origins.
Earth.
Yeah.
So
So
Or could we set the origin as L2?
X is gone.
Yeah.
Yes, you can.
Yep.
Okay. Excellent.
yeah, so you would create a libration point L2 and then add that,
That's
and then
So
you
it
can
knows how to
set.
compute a libration point?
What was that, Don?
It knows how to compute a libration point.
It just solves the quintic. I mean, it's
That's fine.
kind of an osculating libration point, basically.
Yeah.
Is it solving the after the integration steps?
It solves it when it kind of at runtime. So if it sends in a time that says, "Oh, I'm supposed to plot this right now," the coordinate system gets a time and it solves the quintic at that time. So it dynamically changes as it gets used.
That's what
Okay.
So yeah, coordinate systems are very flexible. and Great also.
We set it to 1.5 million. It's just hard coded.
Sorry about that eccentricity. The Earth orbit.
And then, if you perhaps wanted to create two spacecraft and propagate them simultaneously, like I said before, you just add another spacecraft there, and it'll propagate them both in one command. So you just do low Earth prop and then a comma separated list of spacecraft, and it'll do it simultaneously.